Our last thing that we're going to be looking at in our quadratic unit is linear and quadratic systems. Now, we know that a system is an equation, two or more equations in which they have a common solution, or infinitely many solutions, or a no solution situation. In this case, we're going to be looking at where one equation is a line and one equation is a quadratic. Now, you can do this by graphing, you can do this by substitution or elimination. It really doesn't matter. When we're looking at the graphing portion, you are going to have three different options, like I said. You are going to have a no solution option if, for instance, you have something like this, where your quadratic is never going to touch that linear or that line. There is an option for a one solution. It's going to look something like this, where it just touches it once. And then there will be an option of a two solution. So graphically, these are our options here. We won't have an infinitely many option because a line can never be a quadratic, so they can't match up perfectly that you are going to have more than two solutions. You will either have none, one, or two. But what you would do in order to look at this is you would go on Desmos, graph your two equations, and find those intersections where they are located. I'm not going to go through an example like that just because I think that one we've done that enough that you kind of already have an idea. However, let's look at a substitution system. So for instance, let's say that I have y equals negative 3x squared plus x plus 4 as my first equation, and then my second equation is going to be 4x minus y equals 2. So if I'm using substitution, you need to get a single variable by itself, which, if you notice, that first equation already has that. So we're going to take that, and we're going to plug it into this y spot. When we do that, we're eliminating having two variables in an equation. So we actually have 4x minus negative 3x squared plus x plus 4 equals 2. So like I said, that eliminates that y, so we just are in terms of x. So currently this is 4x plus 3x squared minus x minus 4 equals 2. So I'm just going to solve this. You could use the quadratic formula, you could use factoring. There's lots of different options you could go with this. But in all of those situations, you have to get everything on one side and equal to 0. So if I notice here, I've got 3x squared plus 3x minus 6. Right away, I can see they're all divisible by 3. I'm just going to factor that out. It's going to make it a little bit easier. I'm going to divide everything by 3. So x squared plus 1x minus 2 equals 0. Now I'm working with better numbers. Personally, I am going to factor using the AC method. So I've got 1 times 2. 1 and 2 is going to give me that set. So I split that 1x with this combination here. So now I'm going to group factor. X is what they have in common in that first grouping. In my second grouping, they have a negative 1 in common. All equal to 0. So my factors here are x minus 1, x plus 2 equals 0. So I'm going to set each one of those equal to 0 and find my solutions for my x's. X equals a positive 1, x equals a negative 2. Now normally we'd be done, but we are trying to solve the system. So I have to take that x equals 1 and x equals negative 2 and plug those back into these original equations. With that being said, I'm going to plug them into the linear one, that 4x minus y equals 2. So this way I can find my y. You could also plug them back into that very original one with the x squared. That's no big deal. So when I get this, y here is going to equal 2 on that situation. And on this situation, y is going to equal negative 10. So our final answer then is a coordinate because we have an x and a y. So it's 1 comma 2 and negative 2, negative 10. We could have solved this by graphing, like I said before, or you could solve this by substitution, get some algebra if you don't have a computer, where you're just substituting stuff in order to look at that. The last thing is solving a linear quadratic system of inequalities. Just real quick, just as a brief reminder, since we've done this before, because it's talking about shading and that kind of stuff. So if we're talking about inequalities, if I were to have y is less than x plus 2, and then I had y is greater than x squared plus 4. Okay, so in both of these situations, what you're doing is you're graphing this just like we would any other inequality. So if I have that y is less than x plus 2, I'm going to graph that equation of that line, which we've done graphing of lines before. This is going to be dashed, a dashed line, and we are going to shade. It's not eating the y, so we are shading we are going to shade below. So I'd shade that below. Then for this one, we would graph that. Ooh, poor choice on my part. I have it clear up here. That is a solid line. And looking at this, you are shading above, which means in between. So that would be where your solutions lie. Again, shading of inequalities, we've done that before. So it's just a combination of combining them together.